Let's start. Today, we will start to talk about how to design tension member in truss. Just a reminder, I will narrate the story from the beginning. We have area of land and we need to cover it to build our house. So you guys started to select a main system. So we selected our main system, looks like a truss in this shape, which is a typical one. And you decided that this truss will be distributed at equal spacing in this way. And we have purlins in this way, and these purlins will be located at each joint of this truss. So far from this plan and your main system truss, we can figure out what is the distance S and what is the distance A and what is the distance A prime. Then you will start to figure out what is the value of dead load at each joint of your truss, what is the value of live load at each joint of your truss, what is the value of wind load at each joint of your truss, and keep in your mind your wind will be suction and perpendicular to the inclined surface. And also, finally, what is the snow load at each joint of your truss will be vertical load. After you calculated these loads as a concentrated load at each joint, we used the last meeting RISA. And we defined many combinations. If you remember, we defined these combinations to combine according to ASCE 7. Once you define your combination and make run or solve on RISA, you will get this final results. That makes sense? So we will have axial force in each member of the truss. For example, if you look to this member, we have axial force 188.5. For example, this member, we will have axial force, this value 189.7, something like this. Keep in your mind, these axial force in each member of your truss can be tension, force, or can be compression force. We will have a value called P ultimate. This P ultimate can be read from RISA results after you solved your truss under the effect of the loads you calculated before. This force, which is called P ultimate, can be tension force. All the members at the bottom of your truss will be under tension. All the members at the top of your truss will be under compression. For diagonal members like this one, or vertical one like this one, and vertical one, sometimes we have tension, sometimes we have compression. Any blue color will be compression. Any green color will be tension. Any question so far? So guys, this story is very important. This story is part of our course. and will be part of your project, capstone project, or even the project for this course. The story started with, we have area of land need to be covered. We selected our main system. So far, it's a truss. We started to put your layout so we can figure out the distance S, which is the spacing between main system. And if based on your truss dimension, we can figure out the value A and A prime. Based on these values, we can figure out how much did load, live load, wind load, snow load. Then I can use RISA analysis to solve this truss. The final conclusion from RISA will be these results. So the final conclusion, I will design this member. This is what I will cover today. We have a member under the effect of a value called P ultimate. This value is tension force. So our topic today is talking about design of truss member, not any member, but the truss member under tension. Under tension, because we have members under compression, will be covered next week. But so far, I will cover today the member under tension. And keep in your mind, this member under the effect of P ultimate, and I know what is this value from RISA. Guys, do you have any questions so far about what will be covered today? It's very important to build this story and to understand what's going on, how to start your project, from scratch. So today I will cover the design of these members, not all of them, but the member under tension, because we have members under compression, will be covered next week. So let's start to see what's going on with the design of tension members in your truss. Typically, here is your truss. Here is your main system. We will focus right now on the tension member, which are the members that are subjected to axial tensile forces. How to know these values? I told you, we will solve our truss using RISA. RISA will give you the values of tension and the values of compression on or in each member. So far, we will focus on the tension member. Later, we will cover the compression member. Keep in your mind that these members, the typical members in your truss, will be angles. If you remember, I told you before, your angle looks like this. Can be called 5 by 5 by 1/2. Inch, inch, inch. What is the meaning of this name? The meaning is the length of this leg is 5 inch. The length of this leg is 5 inch, and the thickness for the two legs will be 1/2 inch. Sometimes it's only one angle. Sometimes it's a double angle. It's called double angle, back to back. Back to back means this back of this leg parallel to this back of this leg. Sometimes, and we don't prefer this, your angle is with an equal legs. What you mean by unequal legs? We have a longer leg and a shorter leg, and it will be written like this: 5 times 3 times 1/2. So the name of this angle is different. The first number is the longest leg, 5 inch. The second number is the shortest leg, 3 inch. And the 1/2 is the thickness for both of them. We don't prefer this one because we will have eccentricity. We prefer your angle will be with equal legs. That makes sense? Sometimes we will put the double angle or the two angles like a star shape. This shape. Here is the first angle, and here is the second angle. Both of them looks like a star and connected together. You will ask me a good question. How can we connect the two angles like this together? It's very easy. I will put plate here. So this angle will be bolted to this plate, and this angle will be bolted to this plate, so we can connect both of them together. This is called a star shape, but this is not common also. The most common member in your truss, like this one, like this member, it's one angle, equal leg, one angle. Sometimes we have two angles, like this one, back to back. So this one. So the most common members used in your truss will be single angle or double angle. For your information, your truss will have top members and the bottom members. 90% of these members will be double angle. And then we have the web of the truss, which are the vertical members and inclined members. Most of the time, 90% of these members will be one angle. So keep this information in your mind. If you look to this picture, you will find what I said. If you look here, this member which is inclined, this one is inclined, is single angle. This one is vertical, and this one is top, and this one is bottom. You will find them double angle. What I said is just a recommendation. Sometimes you can find something else. If you put your top member one angle, I cannot say it's wrong. If you put your vertical member double angle, I cannot say it's wrong. But the most common members used for the top and the bottom will be double angle. The most member used for vertical and inclined member is the single angle. Do you have any questions so far? Do you have any questions so far? Okay. Keep in your mind also, we covered this at the first meeting in this course. We have tables. 4 angles. It's not your choice. It's not your choice to select any dimensions. No. We will open our table to select the name of your angle and what are the properties, dimensions of this angle. Based on what, we will cover this today. Keep in your mind that we have a value called P ultimate. This value of P ultimate is the factor tensile force in the truss member obtained from the structural analysis using RISA. I told you at the beginning. We already solved our truss. And we found what is the axial force in this member or in each member. In our case, we are focusing on the tension members. So we are aware that we have a value P ultimate coming from RISA analysis, from this diagram. This is the value of P ultimate. So keep in your mind the philosophy of our design to make sure your P ultimate from RISA analysis, from structure analysis, must be smaller than or equal your design strength. Phi Pn. Phi, if you are talking about case of yielding failure, 0.9. If you are talking about case of rupture, 0.75. This is Phi. Pn can be this value or this value. So looks like we will have 2 values for Phi Pn. The first value will be 0.9 if yield area gross. First term, if yield area gross, because it's yielding, your phi will be 0.9 for yielding. The second case or the second value will be 0.75 if ultimate area effective, which is the second one, case of rupture. In this case, your value of phi will be 0.75. I believe you are aware for this design philosophy before. If you remember, we learned that M ultimate must be smaller than or equal phi Mn, the same philosophy. We learned also P ultimate must be smaller than or equal phi Pn. So keeping this in your mind, and the value of phi based on the standard, in this case, in our steel design course, will be 0.9 if you consider this case of failure, will equal 0.75 if you consider this case of failure. Looks good, but can you tell me what you mean by F yield and F ultimate? Everybody, you are aware that for any steel material, we have a stress strain curve. This stress strain curve looks like this. If you are talking about yielding, this is the value of F yield. And the highest value here is called F ultimate. So F yield is the yield stress of your steel. F ultimate or Fu is the tensile strength. This is the highest tensile strength of your steel. I can understand this material properties, F ultimate and F yield. And keep in your mind, we covered this before. Based on the type of steel, we have a table, can tell you what is the value of F yield, what is the value of F ultimate. What is the value of F yield and what is the value of F ultimate based on the type of steel. We have different types. One of them is called steel 36 or steel A992. Based on the type, we have a table can give you what is the value of F yield and F ultimate. So looks good. What about area gross and what about the area effective? Area gross is the gross area of your member. Since your truss or your member looks like angle, this angle has area cross section. This is called area gross. If you have double angle, so the area gross will be the area of the two angles. So area gross, this value can be located from table of the angles. Area effective is the effective net area. What you mean by the effective net area? Let's talk about this in this slide. In case of bolts, because we have this angle will be connected to connection or gusset plate or whatever using bolts. If you would like to put bolts here to be connected with another member, that means you need to create holes and then put your bolts. This hole or these holes will reduce the cross-section area of this angle. For example, if you make section here, looks like we have a hole, we have another hole, so we don't have material here, we don't have material here. So looks like this is the only part of material, this is the only part of material, this is the only part of material. So in this case, area gross not equal area net. That makes sense? So we have net cross-section area. the bolt holes area is reduced from the gross cross-section area to get the net cross-section area. But if you have weld connection, welding, I don't need to create holes because I don't have bolts, but I have just welding. In this case, area gross and the area net will be equal. Do you have any question regarding this point? I'm trying to explain why we have this case and why we have this case. The first case is talking about the member of your truss, this member. This member is here. At this location, we will have connection with another member. At this location, we will have connection with another member. So at these connections, we will have bolts. And these bolts will create holes. And these holes will reduce the area gross to area net. If you subtract the material that removed because we have holes. That makes sense? But this member at this location, we don't have connection. We don't have bolts. We don't have holes. Area gross is still working. So the two cases of design to satisfy yielding will be at the mid of this member. Area gross times F yield. This is the value of Pn. At the location of your connection, since we have bolts, since we have holes, since the area gross is reduced to area net, we will have F ultimate time area effective. That makes sense? So this, the first case of design, will satisfy your member at any point away from your connections. The second case will satisfy where you have connection because the area gross will be reduced because we have bolts. We have equations here, but before going through this equation, do you have any questions so far? I will not consider the second case, or I will consider it, but I will assume area net equal area gross if you have welding connection. If you have welding connection. So based on the type of connection, one day after 2 weeks, probably, or 10 days, we will decide. We will design these types of connection: bolted connection and welded connection. But so far, if you have welded connection, we don't have any holes. We don't have any reduction in the cross section of the member. That means your area net equal area gross. But if you have holes, because we have bolts, how to figure out the area net? We have this expression and this expression according to EISC. So I will write this equation to be area gross minus summation d whole plus 1 divide 16 inch time t. I would like to write our equation to be like this. Area net equal area gross of your member. Most of the time, this area gross from table. Minus summation. DH is the diameter of the hole. Diameter of hole diameter. diameter of hole will equal diameter of bolt diameter plus 1/16 inch. If you have some experience about this, doesn't make sense to create a hole with a diameter exactly equals the diameter of the bolt. Probably your bolt cannot be get in this hole. So we need to make it wider a little bit by 1/16 inch to be easy to put your bolt inside this hole. So the diameter of hole equal diameter of bolt. This is the information will be given all the time in the problem. You need to add this diameter to 1/16 to get the D hole. The diameter of the hole, you need to put this D hole plus 1/16 one more time thickness, the thickness of this plate, and subtract the summation or the total from area gross, you can get the area net. This is the case if you have parallel holes, rows and columns. Sometimes we have staggered arrangement of your holes. When we need to select staggered and parallel, we will cover this later when we are talking about connection. But so far, if you have staggered connection, this equation will be written in a different way. Area net will equal area gross minus summation. D hole plus 1/16 time thickness plus summation S square divide 4G time thickness. So please, I will rewrite this expression in a different way. Area gross minus this expression plus this expression. What is the meaning of S square and G? We will cover this later, but so far, if you have parallel holes, how to figure out the area net. If you have staggered holes, how to figure out the area net. One of you will ask himself or herself a question. We don't have here area net. We have here area effective. We have a relationship between area effective and area net. Your area effective equal a factor time area net. Here we go. This one. Area effective equal area net time U. This value of U can be assumed. We have different value, but can be assumed 0.75. We have expression for U, but I recommend to assume 8.75. Assume 8.75. Okay. So the scenario will be, we have area gross from the table. From this area gross, I will subtract the holes to figure out the area net. I will multiply the area net by 0.75 to figure out the area effective. Then I will multiply the area effective by F ultimate and then by 0.75 to find the first value for phi Pn. The second value is typical area gross time F yield time 0.9. Which value I'm gonna use? I'm gonna use the smallest value. We will have two values. Which value I'm gonna use? I'm gonna use the smallest value. Keep in your mind, the smallest value for phi Pn must be greater than or equal the value of Pn, which is coming from Riese analysis. That means your design will be safe. Your design in this case will be safe. Let's do an example. First example, I will calculate the area gross. I will calculate the area effective for this steel member, steel plate member, or steel plate bar. This steel plate looks like this. 5-inch width, 1-inch thickness, 1/2 inch thickness, and this plate is extended like this. This plate at this end is connected with 6 bolts. And this plate will be under tension. Can you tell me what is the area gross? Area gross without holes means this area equal 5-inch times thickness 1/2 inch equal 2.5 inches square. If you would like to figure out the area net, we have expression. Since your bolts are arranged in parallel pattern, rows and columns, we have expression here for area net. This expression. I will write it here. Area net equal area gross minus summation d whole plus 1/16 time thickness. First of all, your d whole equal d bolt plus 1/16. The given information in this type of problem will be the diameter of the bolts. We are given here that we have a gusset plate with 6, this is a number, 7/8 inch diameter bolts. So this diameter is 7/8 inch. I will add 1/16 inch to figure out the D hole. The diameter of hole will be, let me, 7/8 plus 1/16. I got here, how much? I think 15/16. Probably. Yes. So this D hole equal 15/16 inch. Your thickness of this plate is 1/2 inch. How many bolts? I will not say we have 6. No. If you make cross section here, how many bolts in this cross section? 2. If you did cross section here, how many? If you did cross section here, how many? So the number of bolts, which is indicated by summation. Summation means number of bolts in one cross section. This is the meaning of summation. Summation does not mean the whole numbers of bolts, which is 6. No, no. The number of bolts in one section. If you go back here to this slide, summation means the number of bolts in this section, or this section, or this section. You need only one section. In this case, we have 2. In this case, we have 2. In this case, we have 2. Can you see here? This one will explain it more. Guys, if you did cross section and you need to subtract this one and this one, this one and this one represents only the 2 holes, not the 6 holes. That makes sense? So this cross section equal area gross minus this hole and this hole only, which is the number of holes in one cross section. So be careful about this. So we have here 2 time. And your area gross from the previous step, 2.5. In this case, I can figure out the value of area net. Your value of area net will be 2.5 minus 2 times 1 inch, I think, time 1/2 inch. I got here 1.5. inch square. But your area effective will be area net time U. And I'm going to assume U equal 0.75 time your area 1.5. So your value will be 1.125 inch square. So in this case, we have a member, looks like a steel plate or steel bar. This member has a width 5 inch, thickness 1/2 inch. This member is connected to this connection using 6 bolts. The diameter of one bolt is 7/8 inch. And we need to figure out what is the area gross and what is the area effective. Area gross equals the cross-section area without considering any holes. Area net equal area gross minus summation of area holes on one section only. One section only, not all of them. Not all of them. We have another example. We need to calculate the area gross, area net, and the area effective. Area gross, area net, and the area effective for this member. Do you have any question so far? Guys, do you have any question so far? Garrett, you are the only one here? Nobody responded to me. I need to open your okay, thank you. I need to open D2L to show you something very interesting. The previous examples I solved, it's a given steel rod or steel plate, and the width is given, and the thickness is given. But sometimes in this example, in the current example, we are given angle. Your member in this case is not steel bar or steel rod, which is given 5-inch width and 1/2 inch thickness. No, in this case or this example, this member is angle 4x4x3/8. How can I figure out the area gross of this member? You don't need to do any calculations. You need only to open your table and look for angles. Look for angles. I think we have angles. We have channels. Here you go. We have angles. Which angle? The name is given. 4x4x3/8. So where is it? 4x4x3/8. So we need to go down. Here you go. We have here 4x4. But we have different thickness. We are looking for 4x4 and 3/8. Here is your name of the angle. So in this table, we can find the area. This is the area gross. So this column will give you the area gross of this angle. That makes sense? So your angle 4 by 4 by 3/8 has area gross equal 2.86. Your area gross equal 2.86 inches square from table. You need only to open the table for angles and look for the name of your angle 4 by 4 by 3/8. Then you can find the area gross in this column. That makes sense? If you would like to figure out the area net, we have expression equal area gross minus summation d whole plus 1/16 time thickness. This expression area gross can be 2.86 minus summation. What do you mean by summation? Do you think summation will be 3? We have 3 bolts. Any feedback? What do you mean by summation? Summation means the summation of all holes. Do you think we have 3 holes or 2 or 1? 1 hole, 1. Thank you. Because I will make cross section here or cross section here or cross section here. Any cross section of these will give you only 1 bolt or 1 hole. You will say, hey, if this one give me 1 and this one give me 2 and this one give me 3, for example, which one I'm gonna use? The biggest one. Sometimes, but this is not common. Sometimes your connection looks like this. We have 2, we have 1, we have 2, we have 1. So if you put here cross section, we have 2. In this one, we have 1. In this one, we have 2. In this one, we have 1. Which one I'm gonna use? I'm gonna use 2. That makes sense? So d whole equal d bolt plus 1/16 inch. I believe the given information about the diameter will be related to the bolt. So 5/8 inch plus 1/16 inch give you the d hole, the diameter of the hole. The diameter of the hole will be 11/16. So I will put here 11/16. I will add another 1/16 time thickness. Anybody can tell me what is the thickness of this leg? It's a given, 3/8. Thickness of the leg of the angle. It's given in this name, 3/8 inch. Then I can figure out the area net. So it will be 12 divided 16 times 3/8 inch times -1 plus 2.86. Your area net equal 2.57 or 58. Area effective equal U time area net. I'm gonna assume U 0.75 time area net 2.58. Your area effective will be 1.93 inches square. Looks good. Looks good. Looks good. More example. We are given 2 cases. Case of bolted connection. We have bolted connection for this angle, which is 6 by 6 by 1/2. And we have the same angle, 6 by 6 by 1/2, but connected with welded connection. What is the value of area effective in the 2 cases? What will be the value of area effective in the 2 cases? What is the value of area gross first? Since we have angle, single angle, it's only one angle, 6 by 6 by 1/2, I'm gonna open my table. I will look for 6 by 6 by 1/2. We have here 6 by 6, but your thickness is 1/2. That means this one. 6 by 6 by 1/2. Your area will be, it's not this table. Probably we need this table. We'll give you the area. So 6 by 6 by 1/2, this one. And your area will be 5.77. Here you go. So your area for this one will be 5.77. 5.77 inches square. In the case of bolted connection, your area net will be area gross minus summation d whole plus 1/16 inch time thickness. Go ahead and put your numbers. Area gross 5.77 minus summation. Do you think summation means 6 the bolts, 6 holes, or 2, or 1, or what? I will do section here, section here, section here. Thank you. It will be 2. Summation means we have 2 holes, this one and this one. Time. What is the diameter of the hole? Your d hole equal d bolt plus 1/16. Your d bolt is given the diameter of bolt 5/8 and plus 1/16, it will be 11/16 plus 1/16 time thickness. What is the thickness of this leg? Your thickness is given here in the name 1/2. So I can figure out the value of area net. Your value will be 5.02 inches square. So your area effective will be U time area net. Your U, I'm gonna assume 8.75 times 5.02. Your value will be 3.76 inches square. This is the case if you have bolted connection. If you have welded connection, area gross will be the same like area net. No change because we don't have holes, which equal 5.77. And your area effective will be 0.75 times 5.77. Your value will be 4.3. So do you think welded connection will be better? Yes, because we are saving a material. We are using the full capacity of your material. Due to the holes, due to the bolts, we reduced the area to 3.76 from 5.77. But in this case, in the welded connection, we reduced it from 5.77 to 4.3. We're still good, or better at least. Let me stop here. That's enough for today. We will continue next meeting to complete the design. We still have 2 more examples or 3, but we almost done. Guys, keep in your mind, we are done with the truss solution last meeting. So in this member, for example, we have a value called P ultimate, which is tension. How to design this tension member, we discussed a few concepts today about area gross, area net, area effective, about we have 2 options for design strength of your member to satisfy yielding and to satisfy rupture. And we have 2 expressions to give you the value of Pn. Then based on the value of phi, we can figure out the design strength, and this design strength must be greater than or equal the ultimate tensile force from RISA analysis.